Hello, everyone. Thank you for all of those who are showing up today. It's been a long time since we've done many sessions, so we are happy to see all of you, to all of the PNA followers. I am Salma Al-Hadi, petroleum geologist. I will give you a little bit information about Mr. Ahmed. Mr. Ahmed has a Bachelor of Science in Petroleum Engineering from Suez Canal University with excellent grade. He has an excellent experience in reservoir simulation, reservoir estimation, and production forecast. He is a robust technical knowledge with an emphasis on the field reservoir management and subsurface support, with track recorded in generating opportunities and delivering business results. He is also worked in a different development concept as offshore platform, onshore platform, and subsea systems. He worked on wall upstream project cycle from exploration, appraisal, development, and production stages. So hopefully you will enjoy the session, and I just want to apologize to all of you for being late. And because all of you will be in attendee listen only mood, drop your question in the chat box so it will be answered at the end of the session during the Q&A. So over to you, Mr. Ahmed, and good luck. We are so exciting.
Okay, thank you, Salma. It's a pleasure for me to, let's say, spend these minutes with you. It's a little bit 45 minutes presentation and 15 minutes for question and open discussion. So let's start. Today we are going to talk about a little bit about the fundamentals of field development planning. Actually, we are going today to answer these, let's say, 5 or 6 questions. What is the meaning by field development planning, and why we are plan this, let's say, field development? How we can execute this field development planning, when we shall generate this field development planning, and who is involved for preparation and conduction and so on for this field development planning, and finally who is authorized to sanction this field development planning to go ahead with let's say the activities and start development and production from the field. So as we know, our, let's say, petroleum engineering upstream is divided into 3 main phases. It's exploration. This is the first phase. Development. This is the second phase. And finally is production. And after that, abandonment at the end of the field life. So we are concerning with this middle stage of development. What is meaning by development? It's actually drilling and completion of our wells, and construction, installation of surface facility, pipelines, processing facility, and so on, to deliver our production, whatever it's a gas or oil, to the export world. So we are concerned with this let's say middle stage that is prior to production and after the exploration. So who is involved in development? Actually, all the disciplines are involved in the development. Geologists, geophysicists, engineer, reservoir engineering, drilling, completion, production, and so on. So a lot of people and a lot of disciplines are involved in the development. That is, as I said, it's consists of 2 main, let's say, categories. It's drilling and completion, plus surface facility and production facility. So shall we choose our, let's say, development planning from a various or a lot of options? We have a lot of options. Option first, location of the well, the drilling. Where should I place my wells? I have a lot of options. So which design I should select for my well? It's a vertical, horizontal, multilateral, deviated, and so on. Completion will be single, double, gravel back or not. Artificial lift, shall I use artificial lift or not? Production facility, shall I use water flooding or no? It's a, let's say, natural depletion only, and so on. So I have a lot of options in each category, in drilling and selection, design of drilling, completion, in production subsurface and the production surface facility. So I have a lot of options. Shall I go with one? Which option shall I select? Shall I prioritize and take as my development plan? This is our concern today, is to define our plan from a various of options I have. It's all of these options are visible and can be let's say performed or executed, but which is the best option? This is the question we shall ask ourselves, and we shall let's say exert our effort to select the best one. So to answer the first question, what is the field development planning? What is this? It's a process for evaluating multiple development options. I have a lot of options, as I said, in drilling, in completion, in facility, in production, and so on. So I shall evaluate multiple options. Only evaluation? No, but after evaluation, I should select the best one. So I should evaluate multiple options. I should not go for only one option. No, I should make, let's say, multiple options, evaluate a lot of options, and select the best option. Based on what? This is, we will answer after a few minutes. Based on what is the criteria for the best option. Maybe it's economic, like net present value, economic indicators, and so on. Maybe based on the oil recovery, the maximum oil recovery, based on the operational flexibility and scalability. A lot of, let's say, option I have to evaluate these multiple options during development. Capital and operating costs, technical and operating financial risk, maybe risk, the less risk, I will select the less risk option. So a lot of points I have to consider during the evaluation of these multiple options. Okay, so the field development planning is a roadmap during my development phase in order to select the best location of the well. How many wells shall I drill? Which completion I shall use? Which artificial lift? Shall I start with water flooding or natural depletion, or starting production with EUR directly, and so on? So it's a roadmap for this. A lot of options I have during the development of the field, but during this roadmap, I should optimize the production of my hydrocarbon and select the best one based on a criteria, a certain criteria, as I said. So this field development planning should be after the exploration and before production. I should have a clear plan from a multiple option, which option I should choose and why I have choose this option. So as I said, we consider alternate development option, a lot of option, primary recovery, secondary recovery, tertiary recovery, whatever. I have to evaluate all of these options and select the best one based on the economic criteria, environmental, reservoir criteria, operational criteria, and so on. So maybe my development plan is starting it's not mandatory to start with primary recovery. I can start from the beginning with EUR, for example, because this is the best option. This will give me the best recovery, the maximum economic recovery, and so on. So I shall not, let's say, go in sequence with the normal sequence: primary recovery, secondary recovery, and tertiary recovery. No, I can go from the beginning maybe to the secondary recovery, or maybe to EUR directly. Based on what? Based on the criteria. Okay, so this is the answer of the first question. The second one, when I shall generate this FDP or field development plan. actually, as I said, we have exploration phase, development phase, production phase. We shall generate this field development planning, make this evaluation, make this work, and come up with the best option after the discovery, after I have confirmed this is an oil discovery, and before starting the production. So I should spend some time between discovery and starting production to evaluate these multiple options and select the best one based on a certain criteria. And why I shall start field development planning after discovery? To confirm that there is a potential development project, or this is a hydrocarbon in place. I am not, let's say, I will not generate a field development planning based on, let's say, a hypothesis from exploration only. When I was only in the phase of exploration, I have prospect and so on. No, this is not, let's say, it's not a field development planning, but it's a, let's say, it's a hypothesis. But field development planning come after discovery and before the production. Okay. So only this is the let's say the time stage that I should generate the field development planning. No, this is the common one. But actually there is other let's say time frame within which I can generate a field development planning or revisit our original field development planning or update our field development planning. When this should happen, during any major expenditure. If I need to, let's say, install or study to install water flooding after the primary cut, I should update and revisit the field development plan or generate another field development plan. So during the initial development, during the field expansion, for example, I start my fields on phases, phase 1, phase 2, phase 3. So I shall revisit and update the field development planning before any phase. Maybe the contract terms changes, maybe at late life, before the abandonment of the field, I should make or revisit the field development planning. What were my objective? I have achieved my objective or targets from the field. I have reached to the maximum estimated ultimate recovery, or there is some remaining oil in the field, and so on. So I should first generate during the initial development of the field and during any major expenditure required during the development or the development cycle of the field. Okay. The third question is why? Let's say, why shall I evaluate multiple options and select the best one based on a certain criteria? I can go for the normal one. We drill exploratory well. We drill 3-4 wells around our exploratory well as appraisal, and after that, we can meet together after lunch and spend 1 hour with our manager and come up with a very, let's say, specific field development planning, putting the well into the structure map and drill and put in production. And this is set. No, it's not like this. It's not simple like this. What? Why I shall generate and evaluate multiple options? Because there is no particular goal for our stakeholders. What is the meaning of stakeholders? Stakeholders is the person that's affected by the project or affected by the development project of our field. Maybe my project is one well, only one well, exploratory well, and I will complete and put in production. This is called a project. And maybe the project is multi-billion-dollar project, like we have here in Egypt. We have a great project, subsea project, gas discovery. Up to now, it's cost $11 billion investment. So maybe the project is very large or very small. It's not, the scale is, let's say, is not a factor, but at least I should have a field development plan for this project. either small or big, it's not the matter, but because there is no particular goal for our stakeholders, the operator, the government, the investor, the financer, the partner, the legislator, and a lot of stakeholders, the people who is working on the area and so on. All of these each person have a particular goal. One person needs to maximize the net present value. He is looking for the economic only. Another person looking for the, let's say, local content. I need to maximize our local content in the project. Another one is need to maximize the reserve, maximizing the recovery, and so on, generating cash flow very quickly, minimizing the exposure to the risk. All of these are objective for our field development planning. Who will say that I will prioritize the NPV or net present value, or prioritize the recovery, or prioritize maximizing the reserve, and so on? This field development plan. I should evaluate multiple options. Maybe one option giving me the highest economic, maybe another option giving me the highest recovery, and so on. And based on our criteria, our company criteria, as a government, for example, we are looking for maximizing recovery, keeping production for the longest period, and so on. But maybe the investor, he is looking for the economic only. Maybe another one is looking for generating opportunity, and so on. So all of these goals, all of these objective field development planning, I shall evaluate multiple options. For that reason, I shall evaluate multiple options and come up with only one option that satisfy all of these objectives, satisfy all of these stakeholders. Also, because the challenges in our industry, it's very big. The projects are very large. I said multi-billion dollars. So it's a lot of money. There is a complexity, especially if we have, let's say, offshore environment and so on. It's very complex, very costly, and so on. Maybe the opportunity between economic and non-economic is very small. Not now, because the price is very high, but when the price was $35 per barrel, it's a very narrow margin between the economic and non-economic projects. So I shall evaluate the option to take the best one and take the right decision. Also, I should prepare anyway, you can say that, okay, I will produce, and there is no big difference between, let's say, recovery factor 20% or 22%. No, it's if you amalgamate this loss in, let's say, loss in potential for 10 fields, for the country, and so on, it will be a big number. So to meet the future production challenges, every country needs to maximize the production, to maximize the revenue, to satisfy our needs from energy, and so on. So it's if 2% from this field and 1% from that, and 3%, 5%, and so on. If I lose all of these, so it will be a mess. I should optimize my field development planning to come up with the best development that will maximize the recovery to meet the future production challenging. So I have to evaluate multiple options. Maybe there is one option I cannot figure out. So by making this evaluation of multiple options, I can come up with one option that maybe that not considered from the beginning. Also, as a survey from the industry, there is a lot of let's say potential value, and the actual value is usually is less than the potential value. Why of these losses? As I said, due to the improper planning or improper execution of the project itself. Maybe the potential is very high and I make a mistake because I order, let's say, the surface facility and make some bottlenecking, so I cannot produce my field with the optimum rate. Or maybe the completion of the well is not the optimum one. I selected one artificial lift is not the optimum, and so on. So this lost opportunity will make my actual value of the project is less than the potential value. This is a potential value, and I cannot reach this target due to improper planning or improper execution. Like this figure, it's a little bit tricky, but as I said, the project itself, we have two phases: planning phase and execution phase. So we have four options, let's say, poor planning and poor execution. So I will reach to a very minimum value. Or I have poor planning but good execution, so I will reach to point C. Or I have good planning and poor execution, so I will reach to point B. So the value is high, but I can reach more if I have a good planning and a good execution. So the planning or field development planning is a key factor to reach a very high value from our project. So if I have poor planning and good execution, so I will not reach the maximum potential value of our project. Finally, why we should have a field development planning? Because I have multiple disciplines. As I said, we have exploration team, geologists, we have drilling, completion, production people, reservoir, petroleum engineering, also HSE, legal, and so on. All of these disciplines, it's a multiple discipline. I have to optimize the objective and satisfy the needs of all of these people. Okay, so why field development planning? To identify the most effective strategy, to avoid uneconomic development, to ensure safety for person and environment, to ensure adequate economic return, net present value is a good, to drive maximum benefit and improve reservoir recovery. In order to avoid any loss or unwanted and unplanned loss. Okay. So the fourth question, who is involved in field development planning? As I said, it's a very big team. It's a multidisciplines team consisting of technical people like reservoir, geologists, drilling, completion, production, surface facility, and non-technical people like HSE, engineer, economic expert, and analysis, and a lot of people. So a lot of teams and a lot of disciplines in the team. All of this team, it's an integrated team, and we shall have let's say how to organize and how to coordinate between all of these members on the team. I will discuss later. So the team include technical people and other professional or non-technical people, like as I said, stakeholders like land manager and the logistics, HSE, and so on. So a lot of people in our team, technical and non-technical, and we shall organize our work correctly in order to coordinate and cooperate between all of these disciplines to come up with the optimum planning and optimum execution. So the old approach in the field development planning is in sequence. Like let's say exploration will finalize their work and they will deliver to reservoir. Reservoir will finalize their work and deliver to petroleum, and petroleum deliver to production, production deliver to finance, and so on. So it's in sequence. But the modern one is hybrid, is not in sequence exactly, but all the team shall work in an environment, let's say it's an integrated environment, in order to come up with one best option, in order to highlight the criticalities in a certain point, or let's say a certain stage during the planning. For example, maybe the price is low, very high, I don't know. So I should update our reservoir, I should update my geologist if I have some risk or let's say uncertainty in the model, and so on. So all the team should be in only one team. It's a multidisciplinary team, but only all in one team, not in sequence, but let's say it's parallel, all in parallel, not in series. So for example, this is an example for let's say non-integrated team. Everyone is talking from his perspective and ignoring others. For example, exploration need to maximize the oil in place. Whatever is the number, I need to declare a very big number to achieve the success. Production engineer, I can, let's say, choose the surface facilities. It's very simple, one train only to handle my or process my oil and water, and maybe I can I ignored the water and so on. Petroleum engineer, okay, I can select the artificial lift. That is from my perspective is very easy, flexible to work over and so on. Driller, it's a big mess, by the way. Drilling engineer, maybe if it's not, let's say, involved in the project deeply, maybe they for example, they ended up with a casing design or casing phase is very small and limited to the production capacity of the oil. So all of these teams shall work in an integrated team, and there is a manager for all of these people who distribute the, let's say, the responsibilities and take the feedback from each department or each discipline and coordinate between them. He have the clear objective of the field development planning and need to achieve these objectives. Okay. Coming for the important question. Okay, we know what is the development planning, why and when, who is involved, and how can I, let's say, conduct or make this plan. So really, it's a management approach. We shall not evaluate the option or the multi-option in arbitrary way, but we should evaluate this option based on a science. And this science, let's say, discretize the evaluation process into 3 phases. It's called feasibility phase. After that, concept selection. After that, concept definition. And after that, it's execution. Between each phase, there is a gate. So in each phase, there is an evaluation criteria, not like each other. Here we have an evaluation criteria, another evaluation criteria in the second phase, and then the third phase, and so on. Between each 2 phases, there is a gate. This gate is like a checkpoint. Let's say if this option I have generated and evaluated here met the criteria of the gate, so it will pass to the second phase. If this option not met the criteria, it will be rejected and it will not allow to pass to the second phase. So we will start with the feasibility study or appraisal phase and come up with some option, let's say 100 option. Come to the gate, checkpoint. Please, did you achieve 1, 2, 3? This is criteria, our criteria. No, go back. If you achieve, okay, go ahead. Come to the second stage, concept selection, and we make another evaluation by using another criteria and come up to the second gate. Did you achieve our criteria? Yes, go ahead. No, rejected, back, and so on, until I come up with only one option. So it's a filtration process, but based on the, let's say, multi-layer filtration in order to, let's say, optimize the time and optimize the effort. So let's go ahead in this process, and it's very, let's say, very important. And this is the core of field development planning. So let's start with the first phase. It's as I said, this gate is a checkpoint or a transition point between two different evaluation phases, and we shall met the criteria of this gate. So now we will know what is the evaluation process here in each phase and what is the criteria for each gate, the selection criteria for each gate. So at the beginning, we shall held a workshop for brainstorming to come up with multiple options, a lot of options. Let's say I will not say 100 options, but at least 10 options of development. I put drilling, completion, production, production facility, and so on, and start to make this matrix. I will drill 5 wells. which location, completion, artificial lift, production facility, 1 train or 3 train, offshore or onshore, and so on. So a lot of development option, at least 10 option, maximum it's a 20, 50 option, but it will be a disaster if more than this. So between 10 and 20 option come up from brainstorming or from the workshop between all discipline. This workshop, all the people in the project or shall be involved in this, let's say, in this brainstorming workshop to come with all possible option of development. Okay, and after that, I will go to the first phase. It's the feasibility study. And what kind of evaluation I shall conduct in this phase? I shall, let's say, check if this option I have proposed in the workshop is visible or not. Only this is our target here. It's technically visible or not. Let's say I have a very shallow prospect, offshore, but shallow water. Let's say the water depth is 10 meters. So maybe installation of a platform in this very shallow water is not visible because the water depth is very shallow. But I can drill from the land. I drill directional drilling to exploit this hydrocarbon phase. So all the evaluation process here in the feasibility study, I shall evaluate only if this option is visible or not. It's visible, technically visible. I can execute this option or not. I have, let's say, the technology to make subsea production or no. I don't have this technology in my hand or in my country. I cannot avail this option, so I should execute. So the option only that is visible shall go to the second phase. So the criteria of the first gate is visibility. I generate in the feasibility study or appraisal phase, I generate all the scenario, all the possible scenario, and only the visible one shall go to the second phase. It's concept selection. So only this is the criteria or filtration criteria of the first gate is visibility only. It's technical visible or not. Okay, so a wide range of combination of reservoir strategy, facility option with the production strategy, drilling, completion, philosophy, all of these are evaluated. Only visible options, let's say I come up with 10 options, only 6 options are visible and 4 options is not technically visible due to some reasons. So only from here I have 10 options, only 6 options will pass the first gate. It's visibility criteria and come up to the second stage, which is concept selection. Okay, in the concept selection in the second phase, I should evaluate, make another evaluation. This evaluation is based on 2, let's say, main criteria. It's economic, okay? It's economic criteria and risk. It's economic and risk. Quantify economics and rank by risk. Okay, so quantified economics, I should quantify my economics based on what? Based on the production profile for each scenario. So I should have, let's say, not the simulation model or reservoir simulation, but maybe the production profile coming from material balance, maybe production profile coming from, let's say, decline curve analysis with some assumption, come with only 1 number of reserves and so on. So not necessary reservoir simulation, but it will be, let's say, it will be an addition value, or it will add value if I have a reservoir simulation model in this stage. But at least we have a production profile and make the economic evaluation and a risk evaluation, because maybe the project is very economic, but it's very risk. Why? Because the, let's say, the price is very narrow. The margin between the price and the return from this project is very narrow. So this is a risky project. Or maybe the drilling is very critical and this is a risky project. Maybe the well cost me $10 million, or maybe there is some exaggeration and it will cost me $25 million and so on. So I shall evaluate the economics of each option from the 6 options that passed the first stage and evaluate the risk. And after that, I shall come up only with one option here. After the second gate, it's the best option. Okay, best option based on what? As I said, based on economic, based on the risk evaluation, the technical evaluation. As I say, we shall come up at the end with production profile, or at least the reserve number, But production profile will be the common outcome. And after that, I will make the economic evaluation based on the, let's say, cost of the well, cost of the production, facility, engineering, all of this stuff, construction of the plant, and all of this operation, OPEX, CAPEX, and so on. All of this, let's say, input value I should use during the my economic study. Okay, so concept selection, I make the evaluation for the 6 option. Each option I will evaluate or quantify the economics, rank the risk, and I make ranking. So the highest economics and the least risk should be take the highest rank. So I will come up from the 6 evaluation here with only the highest ranking in terms of least risk and highest economic to come up to the 3rd phase, which is concept definition. So here the gate is the best, and this best is based on the ranking that achieved in the risk and economics. Okay, so this is ranking for the, let's say, the risk and the cost or economic, and that is very detailed. Okay, this is the risk, for example, risk in technical and risk in economic. All of this, let's say, should be evaluated during our evaluation process. Okay, and I will evaluate net present value and utility index, and all of these net present net investment index, and so on. All of these. Okay, so after the second gate, I will come up only with one option based on my ranking, based on the risk and the economic, and come to the 3rd phase. It's concept definition. What I shall do in this concept definition, I should make, let's say, a detailed design. For example, in this phase, the accuracy of the evaluation is not very high. It's a little bit 50%. I take the cost of the well is 5 million, but the breakdown of these 5 million, no, there is not required in this let's say, in this stage. But here in this stage, I should, in this, I select only one option. This is the best one. I should make a detailed design. So what do you mean by detailed design? For example, the cost of the well is 5 million. 5 million, please break down. So casing, for example, should cost me like this number, and the type of casing is 1, 2, 3. Pump, ESP pump, for example, and the manufacturing is that one, size is that one. Reservoir engineering, the perforation, the completion design, the number of wells, selection of deviated, not deviated, all of these. Separator, horizontal, vertical, the capacity, 2 separator in parallel or in series, and so on. So in this stage, the 3rd one is the concept definition. I should make detailed, take over the detailed field development plan. Every small details should be discussed and should be assured, should be revisited again to make sure that this selection is exactly the best one. So in this, let's say, stage, it's a very breakdown from the previous one for only the best option, not all the option, but only for the best option. So I will prepare what is called front-end engineering design. It's a very detailed design for every piece in our project I have selected. So the end at this stage, it's a concept definition. We called concept definition. We make the basic engineering, operation plan, risk plan. Again, all of these evaluation, but in very detailed and very details to assure that our option is the best one exactly, and all of the material is available and can be available during the execution phase. So after concept definition, I come up with the best plan in details. Every detail in each discipline is in place, and I will come to the, let's say, the third gate, and I should assure this concept is economic, and I will take what is called final investment decision. Final investment decision. This is the, let's say, the responsibility of the high manager, maybe the board director and so on, take the final investment decision. Okay, go ahead, I agree for this evaluation, and I will sanction the project and committed fund for starting the execution of the project, whatever this project is, one well or multiple subsea or offshore wells. No matter. So I will come up with the last gate. It's a final investment decision. The manager will take only one option coming up from all of this evaluation process, and this option has detailed design, and we have the cost, let's say, evaluation is very accurate, and the planning or the planning or execution period is clear, the production startup is clear, and so on. So the planning bar, we come with the first, second, and third gate, and after that we will start the fourth phase after the appraisal or feasibility, concept selection, concept definition, and come up with execution. Start after final investment decision, I will start with the execution. I will order the material. It will take, for example, 6 months, 2 years, and so on. So no matter, based on the plan I have selected. So as a conclusion, we have at the beginning the assessment stage, I have multiple options. All of these options for our development come up with the first gate. Only the visible options path through this first gate, evaluating based on economic and rank according to the risk. Come up with the best option. This best option, we make a detailed design, front-end engineering design for this only option, and come to the third gate, which is a final investment decision. It's okay, so it will go through the fourth stage. It's execution, start of execution, not start of production, but start of execution. Execute drilling wells, install surface facility, and so on. Okay, so final investment decision, I should submit my FDP to the authority, whatever the authority. For example, here in Egypt, we have EGPC, in Sudan, I think OPA, and or the minister, and so on. So I have submit my field development planning to the highest authority to take the approval to start as in the execution phase and take the final investment decision. So this is the phases, and between each phase there is a gate with a certain criteria. I should meet the criteria for each gate to path to the next phase and start in the execution. You can ask me if this best option doesn't take the final investment decision, so it will be on hold. The development plan at this time will be on hold, and I will, let's say, make a priority. Maybe I have, for multinational company, for example, ExxonMobil, Chevron, and so on, they have multiple projects around the world. So they take, maybe the project is very good, it's economic and so on, but there is a priority. I have some certain expenditure, and I should make a rationalization for my expenditure. I should not spend all my money in one country, or I should make a ranking or category for each project. So if I didn't take the final investment decision, my development plan will be on hold until I take the final investment decision from the authority. Okay, during the execution, this is the fourth stage. I will, let's say, construct this Gantt chart for subsurface appraisal, drilling facility, pipeline, and so on. All of these activities should be in a project, and we have a Gantt chart to have a clear object or a clear picture of our project. When I will start drilling, when shall I make the contract with the drilling rig, when shall I release the rig, and the material of the pipeline will arrive, and so on. And when shall I start the production? Maybe starting the production take 1 month. As I said, it's a very simple project. Or for example, offshore projects take years for execution phase. This execution phase is a very long period, maybe take 3-5 years as an average, for example, for a huge offshore project. So maybe it take years, it take months, whatever. It's a development planning or a project. So this is the design, manufacturing, and installation, and after that during the operation, maintenance, and so on. So all of this is the sub-stage of the execution phase. So as a conclusion, we come up to the conclusion. Field development practice allows optimal allocation of capital and human resources, reduce uncertainty during this multiple evaluation process for multiple options, and come up only with one option, ensure a full view of the field, and we screening all the available development option to come up only with one option through evaluation or assessment phase, concept selection, concept definition, and execution. And after execution, we shall start the production or commissioning state here. So I take the first all of this stage or sub-stage during the development phase, and here after that I will start the production. So before this is exploration, all of this is development stage, and after that this is the production stage. So appraisal, concept selection, definition, execution, and start production or commissioning of the field. So this is all of this is planning. This is execution. As I said, good planning, good execution will deliver the best project. Bad planning or bad execution will deliver least or less potential project than the expected one, or the potential value of our project. So FDP should be documented into an official document. It should include executive summary about the discovery, the field, introduction, field history, reservoir characterization, or what we said, the reservoir model, and the, let's say, production profile, economic evaluation, drilling completion, the cost, and the project, the surface facility, the installation, execution schedule, and at the end is risk and HSE, and the standards of the governing. Maybe also the contract terms and condition may be included in the field development planning. The production period may be 25 years. There is an extension to another 5 years, and so on. All of these terms and condition shall be also included in the FDP. This is a template, for example, FDP introduction, field strategy, development plan summary, and all of this evaluation process should be included in the assessment phase, concept selection, concept definition, and execution, all of this, and economic evaluation, and so on. So the wells, for example, integrity, abandonment, all of this should be included in the FDP facility. And most, as I have seen, most of the cost, maybe we neglect this point, but most of the cost of development stage or development phase in the facility, in the pipeline, in the plant, processing plant, and so on. So drilling and facility take most of the cost of our, let's say, field development planning. But for example, maybe the cost of drilling and cost of facility maybe cost us millions of dollars, and the study and the optimization of this cost of designing the best drilling and designing and selection of the best facility may take maybe in the manpower 1 million, 2 million maximum as a study. So maybe the manager start to cut some cost from study and ignore this study. No, cost in study will save cost during planning and save cost during execution, because studying will come up with the best option. So it's not a cost, let's say, prosperity, but it's a mandatory to come up with the best option and the best, let's say, development planning to achieve the maximum recovery or maximum economic return. And we shall make some risk management, because all of the data in the petroleum industry, there's some uncertainty and so on. Uncertainty in, as I said, in economic, uncertainty in technical parameters. So we shall conduct this risk management plan. What if, and if this condition happen, what shall I do? How shall I mitigate this risk by using what is called risk register. So I think we come up to the end of our presentation, and the floor now is for questions.
Mr. Serry, we would like to thank you for this outstanding presentation. Sorry for coming late. My name is Mudathir Muhammad. I'm a petroleum exploration geoscientist. Currently, I'm working as a customer service in Ittihad Water Electricity. We would like also to thank you for this very clarifying and detailed presentation about field development, especially from the point of petroleum industry. We have just a few questions from our presence here. We would like also to thank you for everyone who have joined us in this fruitful session. We have a question from Mr. Hassan. The question says that how I can get approval field development planning from government.
Okay, it's based on the, let's say, we called the concession agreement. So after, as I said, when I shall start in our field development planning after, let's say, declare of the discovery. So here in Egypt, for example, I shall submit the FDP to the authority within 90 days from declaration of my discovery. So I have a time period. It's 3 months, 6 months, based on the agreement between the operator and the authority to submit the FDP, your FDP, and this FDP should be detailed FDP, and the authority shall study the FDP and let's say agree for the objective. No, I need to modify some operation point of view. I need to maximize the local content in this project. I need to avail more, let's say, career for the local engineer and so on. So I get approval. I submit as an operator for the concession. I prepare the FDP by using my teamwork, as I said, the integrated team, and submit to the authority. Authority shall evaluate and assure that this FDP met the objective of the government, because authority, let's say, it's delegated from the government to achieve the goals of the government or the goals of the people of the country. So I get approval from the government by submitting a full document containing the stage of the FDP assessment stage, concept selection, concept definition and execution, cost, risk assessment, and all of this stuff we have highlighted during the presentation.
Okay, thank you so much. Also, we have another question. The question says, Mr. Serry, that how we can adapt new technologies like CO2 into field development plan.
Yes, it's no matter the recovery mechanism and for our field. Let's say primary recovery, secondary recovery, tertiary recovery, which is like CO2, thermal recovery, and so on. All of these shall go with the same sequence. I should generate some options. This option should be evaluated, come up with the visible options. These visible options shall be evaluated from economic perspective point of view and risk point of view, make a rank, the highest economics one and the least risk one shall be go to further to the concept definition. In this concept definition stage, I make the detailed design, let's say for CO2, from where I shall get this CO2, the source. After that, which well I should choose to inject this CO2, which rate, okay, the design material, because CO2 is corrosive. Shall I change the production tubing in all the produced well? In the pipeline, shall I inject some corrosion inhibitor in the facility? What shall I do? And so on. All of these economics, maybe after all of this study, I come up with, no, sorry, the cost of oil now is very low. It's $30 per barrel. And my break-even price for this CO2 project is $40 per barrel. So this project is not economic. I will, let's say, I will not go ahead and in the execution phase. So I will not get the final investment decision, and the development of this field or this stage will be on hold. Or maybe the government take the opportunity, no, go ahead, because it's a research and development project. For example, this is one objective. Maybe the project on the paper is not economic, but as a return on the government, on the international company, they need to make a pilot and see the response of the reservoir. Say, so they may spend some money to get some data, some result that can be further evaluated or used for more optimization planning on the let's say on the future. But as a let's say in general, it's the same sequence for any recovery mechanism, whatever primary, secondary, tertiary, no matter. It's the same sequence, the same stage, the same criteria, the same evaluation, and so on.
Okay, thank you for answering those questions. We have, I think, the last question is coming from. It says the question. It says, is it easy to detect if the meaning of the field plan change over the time? Like the meaning of the field plan changing over the time. Is it easy so we can follow up with a specific kind of materials or?
Yes, I can. I have, let's say, a template for the field development planning or a project. It's published on the internet, so I can forward to the coordinator, and he can forward after that to all of the interested person. But as I said, the field development planning, it's not during the initial development only, but it can be revisited and updated again during the field expansion. For example, I have the south part and I develop this part, and there is a northern part. So I shall revisit the development planning. Maybe the contract terms and condition changed. I have a new operator, new partner. Maybe the cost recovery changed and so on. So I shall revisit again the field development planning. And also during the, let's say, before any major expenditure, I shall, let's say, I'm thinking now to apply the water flooding project. Shall I apply now, or I wait till 2 years from now, or I shall, let's say, I am too late, I should go for the enhanced oil recovery directly, and so on. So before any major expenditure in the field, I should revisit and update my initial field development plan.
Mr. Serry, would like to thank you for this outstanding clarification for the answer we have received from the present here. And also would like also to appreciate your more explanation for this very important topic, field development, especially, as I said before, from the point of petroleum industry. I just would like to remind the presence here that the session is recorded and it will be available for YouTube channel. So you can come to them anytime that you need. Be sure to follow us to get what we have lined up for you. And I would like to thank you so much for joining us in this fruitful presentation with Mr. Serry. And now we come to the end of the presentation. And thank you so much, and bye-bye.
Yeah, thank you. Thank you all for your time, and I hope you get the full value from the presentation.
Thank you so much.
Thank you.